This is the first of a couple of videos on finances. So we're going to begin by our study of finances by discussing compound interest. And let's begin with an example. So we will assume that we have invested $500 in an account that pays 24% annual interest, compounded monthly. It's a fairly high interest rate, but it makes the numbers easier to deal with for this first example. So we will be using a capital P for the beginning amount. This is sometimes called the principal or present value. That's the reason for the letter P. In our case, P is 500. We're beginning with $500 invested. We will use lowercase r for the annual interest rate, and in decimal form. In our case, the interest rate, annual interest rate, is 24%, so r is 0.24. N is the number of compounding periods per year. So in our example, we are compounding monthly. So that means interest will be compounded 12 times per year, so our lowercase n is 12. T will be the number of years the money is left in the account. That's not specified in this problem. And we will use A for the ending amount of the account, the amount at some later time. So A is sometimes called the future value of the account. So these are the symbols that our textbook College Math uses. The other textbook that we're using, Math and Society, uses slightly different symbols. Two differences, actually. Math and Society uses K for the number of compounding periods per year instead of N. And Math and Society uses capital N for the number of years the money is left in the account, whereas we are using a lowercase t. So when you're reading the book Math and Society, you'll have to be aware of that difference. So what does compounding mean? The meaning of compounding monthly we're going to begin with. Okay, so first you find the monthly interest. So remember, the annual interest, the yearly interest, was 0.24 or 24%. We want to split that equally among the 12 months. So the monthly interest will be 24 divided by 12%. That's 2%, or 0.02. Always put our interest rates in decimal form. So compounding monthly means that during each month, the amount in the account is increased by 2%. That's the monthly interest. And from that point on, the new amount begins to earn interest. That's the compounding part of compound interest. So remember, if you want to increase something by 2%, you multiply by 1 plus 0.02. So how much will be in the account after 1 month? Well, we began with $500. After 1 month, the $500 will be increased by 2%, which we do by multiplying by 1 plus 0.02, and that gives us $510 in the account at the end of the first month. How much will be in the account at the end of 2 months? Well, during the second month, the new amount, $510, earns interest. So we want to take the 500 times 1 plus 0.02 and increase that by 2%. In other words, after 2 months, we will have $500 increased by 2% twice. The shorthand for 1 plus 0.02 times 1 plus 0.02 is 1 plus 0.02 squared. And when we do the calculation, we get $520.20. Do a little more calculating. How much will be in the account after 5 months? Well, 500 times 1 plus 0.02 to the fifth. We want to increase the 500 by 2% 5 times, one for each of the 5 months. So in words, this formula says increase the 500 by 2% 5 times. How much will be in the account after K months, where we're using now a variable instead of 5? We want to increase $500 by 2% K times. So 500 times the quantity 1 plus 0.02 to the K. How much will be in the account after 3 years? Well, let's see, 3 years is 3 times 12, or 36 months. So we want to increase the $500 by 2% 36 times. 500 times 1 plus 0.02 to the 36, which, when you do the calculations, is $1,019.94. So interesting to notice that at this high interest rate, in 3 years, your money is more than doubled. How much in the account after T years? Now we're looking for a more general formula. Well, we want to increase 500 by 2% the number of months in T years. You get the number of months in T years by multiplying 12 by T. And now I want you to remember that the 0.02 is the monthly interest rate, right? We got the 0.02 by dividing the yearly interest rate, 0.24, by the number of compounding periods in a year, by the number of months, which was 12. It's the 0.02 is R over N. So if we are looking for a completely general formula for compound interest, if we want to write the formula using variables, P for the beginning amount, R for the annual interest, N for the number of periods, compounding periods in a year, and T the number of years, the formula would be A equals the beginning amount times the quantity 1 plus R over N. Remember, R over N is the monthly interest, raised to the power N times T. So N times T will be the total number of compounding periods. So in the problems that you do, you won't have to worry about deriving the formula, just using the formula. So here is the compound interest formula. If you make one single deposit at the beginning and let it sit, this is how to calculate the ending amount. So let's try an example more like the problems you'll be doing. An account pays 2% annual interest, compounded monthly. So this is a more reasonable interest rate, annual interest rate, than 24%. Okay, so let's suppose that you invest $1,000 in this account. How much will you have at the end of 8 years? Well, we're plugging into the formula. The beginning amount is 1,000. We multiply that by the quantity 1 plus the annual interest divided by the number of compounding periods in a year. That's 12 because we're compounding monthly. And then we raise that to the power 12 times 8. We're going for 8 years, so 12 times 8 is the number of months in the 8-year period. And if we do the calculations, we get $1,173.35. I just want to talk briefly about how you might enter that in the Desmos online graphing calculator. So we are multiplying 1,000 times the quantity, 1 plus 0.02 divided by 12. Now in Desmos and on some graphing calculators, you will have to hit the right arrow key to get out of the denominator, which I just did. And then a right parenthesis. And now we want to raise that to the power 12 times 8. So remember the up arrow, Shift 6 on most keyboards, takes you up into the exponent. And we want to enter open parentheses 12 times. Remember the times is the star is Shift 8. 12 times 8. Close the parentheses. And now the final amount is shown here, $1,173.35 rounded to the nearest cent. Okay, let's try another example problem. So we're using the same account as in the previous problem. That's 2% annual interest compounded monthly. Well, let's suppose that you need to have $1,500 in 4 years. How much do you have to invest now? So this is like the previous problem, except that in this problem we know the ending amount. Capital A is 1,500, and we need to find the beginning amount, what we have called P. So just a reminder, R, the annual interest is 0.02, and the number of compounding periods per year is 12. T is 4. We're going for 4 years in this example. The ending amount is 1,500, and we want to find P. So we will plug into the compound interest formula. We'll be replacing A by 1,500. P is the unknown. We won't replace P. And R is replaced by 0.02, N by 12, and T by 4. So there's what we get after we do the replacement. Now I'm going to do this calculation. The quantity 1 plus 0.02 over 12 raised to the power 12 times 4. So I get 1.08321493,108. Don't do any rounding when you do this calculation. And now we are interested in finding P. So we're going to divide both sides by this multiplier for P. And that will give us P. 1,500 divided by this number in parentheses is $1,384.77. Round to the nearest cent at the end. Okay, let's try an annual percentage yield calculation. This is something that hasn't come up yet in these slides. So what is the annual percentage yield of an account. APY is the usual abbreviation. So you will see this figure given in bank advertisements, for example. If they're advertising an account, they will tell you what the annual percentage yield is, and here's what it is. It's the percent increase in the account over a year's time. So we are looking at this account that paid 2% annual interest and was compounding, took place monthly. So I want to calculate the percent increase in the account over a year's time. Not 2%. The compounding will mean that the annual increase is a little bit more than 2%. So how do you calculate the percent increase in a quantity? As we know, you take the ending value minus the starting value, and you divide by the starting value. Okay, so I'm picking a number out of the air. Let's suppose that you begin with $200. We will get the same result with any starting value. So this is a sort of a random choice. Then we can calculate the ending value after a year using our compound interest formula. The ending value will be 200 times 1 plus 0.02 over 12, raised to the 12 times 1. Right, we're going for 1 year. And the starting value is 200. So those are the two figures we need to find the percent increase. Ending value minus starting value over starting value. So here I have plugged in 200 times the quantity 1 plus 0.02 over 12 raised to the 12th for the ending value, 200 for the beginning or starting value. And now this 200 will cancel with these two 200s. The simplified form will simply be 1 plus 0.2 over 12 to the 12th minus 1. If I do the calculation, I get 0.0202 or 2.02%. The annual percentage yield, the actual amount by which the account increases over a year's time, is 2.02%. So notice how the 200 canceled. The starting value that I chose sort of randomly didn't really matter. So the formula for finding the annual percentage yield is this. Annual percentage yield is 1 plus r over n raised to the m minus 1. And now there is a short section on these slides about the number e and continuous compounding. So we won't be using continuous compounding. So I will leave the rest of the slide presentation for you to read if you are interested.